I am Tangashakti from AAA Department, Rohini College of Engineering and Technology. Subject code is EE8591 Digital Signal Processing. In this video, we are going to see about basics of digital signal processor. So, from this session, the students can able to understand the concept and evolution of digital signal processors. So the digital signal processor is a specialized microprocessor chip with its architecture optimized for the operational needs of digital signal processing. And the digital DSPs are also fabricated on mass integrated circuit chips. A digital signal processor and microcontrollers are microprocessors that are programmed to execute specific tasks or applications as assigned by their users. Here we have broadly two types of processor: general purpose digital signal processor and one is second special purpose digital signal processor. So the general purpose digital signal processors are basically high speed microprocessor with architecture and instruction sets optimized for DSP operations. So it include Texas Instruments TMS 320C5X, TMS 320C54X and Motorola DSP 563X. And some floating point processors such as TMS 320C4X, TMS 320C67XX and analog devices. Next, the special purpose digital signal processors consist of hardware designed for specific DSP algorithm such as FET, and also have the hardware designed for specific applications like PCM and filtering. So next we are going to see the evolution of DSP processor. So the first one, TMS 320C3X. So it's the generation of first Texas Instruments. So it's a 32-bit floating point digital signal processors. The C3X devices provide an easy to use and high performance architecture, and it can be used in a variety of areas including automotive applications, digital audio, industrial automation and control, data communication and some office equipment like multifunction peripherals, copiers and laser printer, etc. So the next one is the TMS 320C4X processors. So these devices are 32-bit floating point digital signal processor. So it will be optimized for parallel processing. Next, the C4 family combines a high performance CPU and DMA controller with up to 6 communication ports to meet the needs of multi-processor and input-output intensive applications. Next, these processors are used in wide variety of applications like 3D dimensional graphics, image processing, networking and telecommunication base stations. So next one is TMS 320C5X. So this processor accepts source code from the C1X, 2X, C2XX generations. So it's having faster cycle times, on-chip memories, a parallel logic unit, zero overhead, context switching. So next one, the TMS 320C54X processor. So it's a family of 16-bit fixed point DSPs. The TMS 320C54X processors target high volume, low power applications. So normally the first family members were introduced in Japan in 1994. So next one, TMS 320 C55X. So it's a 16-bit fixed point packaged DSP processor family from Texas Instruments. So it can execute up to 2 instructions in parallel with instructions weights varying from 8 to 48 bits. It is based on the earlier TMS 320 C54 family but adds some enhancement to the older processor architecture and instruction set. And the TMS 320 C62XX is the another fixed point DSP processor from Texas Instruments. So it's also based on VLIW architecture. So the next one, TMS 320 C64X. So it's a 16-bit fixed point family of packaged DSP processors from Texas Instruments. So this is the extension to the Texas Instruments. So it's used for the normally this processor family targets high performance applications like wireless base stations, digital subscriber loop, multi-line modems, ISDN modems imaging, 3D imaging applications and video applications. So next one, TMS 320 C67X family. So it's a floating point version of Texas Instrument. So it's also based on the VLIW architecture. And the last one is the Dsp21XX. So it's the first processor family from analog devices. This family consists of a large number of processors based on a common 16-bit fixed point architecture with a 24-bit instruction word. So it's used in modem audio, PC multimedia and digital cellular applications. Next we are going to see the applications of programming digital signal processor. First one is a communication system. So these processors have been applied to implement various communication systems, examples caller ID, cordless handset and many other. So next one, audio signal processing. So here the audible signals cover the frequency range from 20 to 20,000 Hz. So the DSP processor applications to audio signal processing can be classified into 3 categories according to the qualities and audible range of the signal professional audio products and consumer audio products. So next one, control and data acquisition. So the DSP has found numerous applications in modern control, data acquisition applications as well as. So several control applications are implemented using Motorola DSP 5660 PDSPS. Next one, biometric information processing. So this processor find applications in bioinformatics, handwritten signature verification, one of the biometric authentication techniques. So it will be cheap, reliable and non-intrusive to the person being authorized. So last one is the image or video processing. Existing image and video compression standards such as JPEG, MPEG are based on the DCT algorithm. So it's used in many applications like digital cellular phones, automated inspection, vehicle collision avoidance, voice over internet. Thank you.